Okay, we're looking at representing data. So we'll focus on the 6 main methods of representing data, and then we'll do a couple of exam style questions at the end. So I've just made up some data here, right? So we can practice these methods. So let's say, we've got the height of various students in a class, it's going to be like year 7 students or something. This is the frequency and, how many students fall into each height category. So there are 5 students between 1 and 1.2 meters tall, for example. And then we've also got a cumulative frequency. So we just add up all of these as we go. So we've got a total of 30 students in our class. So this is our kind of raw data that we've collected. And now we want to represent that in a nice, easy to digest form. So let's look at bar charts first of all. So we are interested in the frequency of students. So that's going to be on our y-axis. And we know the maximum frequency is 13. And so that's going to be my maximum. Well, let's call this 15. This will be 10, and this will be 5 to go as a scale. And then to save time, I'm just going to use A, B, C, and D as our categories for heights. I've just labeled these for brevity. So, all we do is we look at the fact that we've got 5 students in the first category, category A. I just realized I've put 15 there, not 5. There we go. And we therefore just draw a bar chart like that. In category B, and also our bars should really be touching here because this is continuous data, right? So I should actually make sure that my bars touch each other, because we're kind of arbitrarily deciding where one category ends and the next category starts, right? We just made up the fact that we're going to cut it off at 1.2. Category B, we've got 10 students, so I draw another bar that is 10 high. Category C is 13 students, so I draw another bar that's 13 high. And category D is just 2 students, so I draw a bar that's just 2 high. So that would be my data in a bar chart. Pictograms. So again, let's say we've got category A, B, C, and D. And let's say a circle. Do I do a circle? It might be nicer if I do let's do a hexagon instead. Let's say a hexagon represents 5 students. I may or may not regret this. It equals 5 students. I'm going to turn this into a pentagon. It's going to be nicer as a pentagon. So if we know a pentagon is 5 students, for our first class of A, 1 to 1.2 meters tall students, we've got 5 students, and so I can just draw one pentagon. Simple as that. That represents 5 students. B is 10 students, and so I'm going to now draw 2 pentagons, right? And that'll be 5 plus 5 gives me 10. Category C, I've got 13 students that I need to represent. And so I know I'm going to have at least 2 whole pentagons. But I now need to represent 3 more students. And so it's going to be 3/5 of a pentagon. And so if I roughly do this, that's my center. It's going to look roughly like that, right? That's kind of 3/5 of a pentagon. I've kind of cut off those 2/5 there. Finally, D, I need 2 students. I know pentagon is 5 students, and so I need 2/5. It's going to look roughly, if that's my center, it's going to look roughly like that. It's 2/5 of that overall pentagon. So that's pictograms. Pie charts. Pie charts, we start off with a big circle, like a pie. And we want to work out how we represent each of these 4 categories as a segment of our circle. Well, we need to know exactly what the angle of each segment is that represents each of these 4 categories. And so if my first category, I've got 5 out of a total of 30 students. So I've got 5/30ths of my overall class is in category A. Well, that's the same as 1/6 if I simplify that down. And I now need to work out 1/6 of this total circle. Well, the total circle is 360 degrees. And so I just do a sixth times 360. And that gives me 60 degrees. And so if I had my protractor, I'd measure out 60 degrees, and that would be category A. And we do the same thing for all the categories. We'd end up with a full circle and our pie chart. Cumulative frequency. So we're now using this third column. And so if I start off with my axes again, I'm going to have, this time we're looking at the kind of the continuous version of this data. So I start off at 1 meter tall, and I end up at 2 meters tall. This could be 1.5 in the middle. And so in this case, all we're doing is, well, actually, I might just keep it in categories, keep it looking like the other chart. So we've got A, B, C, and D. Let's keep it like that. And so looking at this, I've got, I'm going to have a total of 30. Let's say it's 10, 15, 10, 20, and 30. So I know category A is just 5, and so I can put 5 there. Category B is 15, and so I put 15 there. Category C is 28, and so I go up to 28 there. And category D is 30. And we could join those up if we wanted to. That would be our cumulative frequency graph. Looking at box plots, I won't go too far in depth into box plots, but this is where we have a range, a lower quartile, upper quartile, and a median. And so this is my minimum in my data. This could be, one student could be 1.05 meters, right? They would represent that. The lower quartile is, if we split our data into 4 chunks, this is the minimum of the middle half, the middle 2 chunks. And so this is my lower quartile. This is my median. So if I put all my data in a long line from smallest to largest, this would be the middle number in that long list of numbers, of heights. Up quartile, which is the same as the lower quartile, but it's the maximum of that middle 50% of my data. And obviously this final line is my complete maximum. It could be a student that is maybe 1.9 meters tall. Finally, histograms. Histograms are slightly different, right? So in histograms, the area of the rectangle represents the number. And so what we need to do is we need to first consider the width of this. So if we are looking at histograms, well, we're going to have height on the x-axis, H-E-I-G-H-T, and this is in meters, and we'll have it's called the frequency density, and you'll see why in a second. So our first histogram bar, well, it's going to have a width of 0.2, right? It's from 1 to 1.2. And we know that the total frequency we need to represent is 5 students. If I want the area of this rectangle to represent those 5 students, well, I know I need to do 0.2 times something, times the height, right, to get 5. What's that height going to be? Well, it's going to be 0.2 times 25 will give me 5. And so I'm going to have a width of 0.2 and a height of 25. So that width there will be 0.2. And the height is going to be 25. Let's say it's going to be roughly that height there. I might make this slightly thicker. Our next bar is going to have another width of 0.2, right, from 1.2 to 1.4, And we need to represent 10 students in this case. So it's a width of 0.2 times some height has to give me 10. Well, I know that 0.2 times 20 times, not 20, times 50 will give me 10, right? So that's 25, and this is going to be 50. And so my second bar looks like this. It's a height of 50 and a width of 0.2. My third bar, I need to represent 13 students with the area. And again, it's got a width of 0.2. And so I need to work out 0.2 times something has to give me 13. Well, on a calculator, I can do 13 divided by 0.2 and I get 65. So my height would be 65 for this. And that's 13 students represented. Finally, if we've got 1.6 to 2 meters, well, that's a width of 0.4, and it's got to be a height of some value where we do 0.4 times that height gives us 2, because the area has to be 2 for this final bar. And so, I can do 2 divided by 0.4, and that gives me 5. And so I know my final height is going to be 5. It's going to be twice the width of the other ones, but quite a bit shorter. And that area represents 2. So that is our histogram. Let's do a couple of example exam style questions. So first of all, let's look at this pie chart. And so again, we need to work out the fraction of the circle that represents 10 out of however many students in total. So first of all, we need to work out the actual total number of students, or was fish in this case, right? So the total number of fish that we've got in our sample. And so I can do 10 plus 23 plus 39, and I'm going to be super lazy on the calculator. That could be 72 in total. And it's the first category, therefore, of perch fish is going to be 10 72ths, right, of the total sample. So that's going to be the fraction of the circle that I need to shade in to represent this first category. So I can do 10 72ths of 360 degrees. That's my total circle. If I do 10 32ths, I think that's the right way of saying it, times 360, I end up with 50 degrees. So we're in degrees here. And so I'd take my protractor and I'd measure out 50 degrees. And I'll just do the same thing with the other two, right? So this one would be 23 72ths out of a total of 360. And again, I would just measure that resulting angle of my protractor. Let's look at a question on box plots. So we've got the minimum is 11. That's going to be our minimum whisker. So we'll draw that in there. Our maximum is 51. So I'll draw in that top whisker in there. Lower quartile is 28. I'll put in the start of my box there. The upper quartile is 42. That's going to be the end of my box. And the median is 37. So I'll draw a line at 37, that point there. And I just put in my whiskers, and that is my box plot. So that's the end of representing data.